So, you want to hear what playing Minecraft would sound like if I could take what I did in the game and turn it into music? Great! That's what I'm doing! But first I need to explain how I came up with this idea because it will help to set the scene. I created a video called Can Music Play Minecraft? There's a link in the description and on the end screen. In this video I tied musical notes to actions in Minecraft. So A would walk forward, A# would open the inventory, B would run, C would crouch, and I did this for each note. I then wrote a program to detect the musical notes playing in a song and to move my mouse and keyboard in the corresponding ways when it heard those notes being played. Now I used 3 songs in that video and I've created many shorts of viewer suggested songs, but they don't ever do much. The most they do is break a grass block and drown. Too many songs just drown. Only a few songs have come close to breaking wood, but none of them have managed it. So I wanted to see if I could create a program that does the opposite of that one and takes my movements and turns them into a kind of song. We can then hear what songs actually need to do to chop down a tree or build a house. And that's what the video was going to be about, until I realized that that wouldn't create anything that sounded like music. That would have just created noise, and noise is not interesting. So now I'm going to tell you a tale of how I actually made music with Minecraft. So at the start, I just reversed the original program, as I said. Now, getting my keyboard inputs was easy. There are a lot of libraries that deal with inputs, both for simulating inputs and detecting inputs. So to explain what I just said, I'm using a programming language called Python. A programming language is like a flavor of code that you're using. Like if it was ice cream, I could be eating vanilla or chocolate. Some people prefer vanilla, others chocolate, but none of it really matters because it's all ice cream. Hope that makes sense. Anyway, some very kind people have written what are called libraries for Python. This is just code that I can use so I don't have to write it out myself, because that would be very time consuming. Without these libraries, it would be like going to an ice cream van and them asking you to milk a cow. Anyway, someone has made a library to detect keyboard and mouse inputs. For the keyboard, this is great, but the mouse code relies on there being a mouse cursor. And, as you might know, there is not a mouse cursor when looking around in Minecraft. So I had to make my own solution. The first thing I thought of was being a proper man and just writing the code myself to get the actual mouse movement and not just the mouse cursor position. And then I would go and lift weights or grow a beard, whatever proper men do. Looking into that, I could see that it was possible, but would take me a while. Writing a program, that is. I can grow a beard in 2 seconds. So I came up with the idea to make a Minecraft mod, because it seemed simpler. This mod would allow me to get the direction the mouse has moved from the game by getting the rotation of the player's head. Now, I'd never made a Minecraft mod before, but with my knowledge of Minecraft and Java programming, it was quite simple. Java's another programming language. It's a lot more grown up than Python. You can think of Python as bubblegum ice cream. Kids love it, but it'd be weird for an adult to order. No planning is put into making it look nice or taste nice, it's just bright blue. Java's more like Raspberry Ripple, a lot more sophisticated. You can see that a lot of time and planning went into making it just right. Anyway, I now have the mod, and each tick it records how the player moved. And it even uses handy /start and /stop commands to start and stop the recording. Everything was going great. Until a wasp appeared and I dropped my Raspberry Ripple! I should really stop using the ice cream metaphor. I'm getting hungry and I don't think anything I'm saying is making sense. Anyway, what really happened was I had a thought. If I move my mouse quickly or slowly for the same amount of time, the program will detect it as the same thing, but the original program moved the mouse at a constant speed, so if I played the song that this program created back through the original program, the mouse wouldn't necessarily move the same amount. So I had to leave my Raspberry Ripple melting on the floor, covered in wasps and a seagull, but there was still hope. At the top of an overflowing rubbish bin, I found a tub of bubblegum ice cream, still cold and with the little spoon left inside, so I made a new program with Python. My idea this time was to control my mouse through my keyboard, so the mouse would move at a constant speed and I could detect it easier. So the arrow keys will simulate moving the mouse in the corresponding direction. Now, if you're one of these weirdos with a small keyboard, yours might look a little bit different, but I'm a real man and I'm not afraid of having all the keys. So above my arrow keys, there is an end button. This will be used to scroll. To the left there is the right control, this will be used to left click, and the numpad 0 is to the right, so this will be used to right click. So I can now move in the same way as the Can Music Play Minecraft script can move. And wow, I didn't realize how slow this movement was and how fast the scrolling was. But I could now get a recording of what it would sound like to chop down a tree, and the result is awful. I even tried making a song. Now, I'm not a musician, and I think you'll agree that this doesn't sound good. Here's Mary Had a Little Lamb. Okay, so now I've got to remember the song and also translate that to my keyboard inputs. Right, okay, so... Now, you might be saying, well, it might not sound very good because it doesn't really sound like an instrument. What is that, a sine wave? Yes, it's just a sine wave. I explained what these are in the first video, but it's just a wave that moves up and down the same amount. The pitch of the note is determined by how many waves it has per second, or the frequency. That's how notes sound different. And like I said, if you want to know more and haven't seen it, check out the first video. It's just a really simple way of creating the sound of a particular note. Anyway, that was my thought too, that it might sound better if it actually sounded like an instrument. So a few things have to change. The first is I started looking into MIDI, or Musical Instrument Digital Interface, and this is what I'm going to be using for the rest of the video. MIDI is a way of storing music, like sheet music, but for computers. With MIDI, you specify the note being played, how long it should be played for, how loud it should be played, and stuff like that, but you don't have to state what instrument is playing. You can, but you don't have to. Instead, you can add whatever instrument you like using something called a sound font. A sound font is just like a text font. You can think of it like sending an email. Billy might send an email to Tilly and write it in Times New Roman, but when it gets to the other side, Tilly might see it in her preferred font of Comic Sans. The data that is sent in the email is just text. It doesn't matter what font you send or receive it in. Sound fonts are just recordings of actual instruments, so when the MIDI file says there's a C note, it just plays the recording of a C note for that instrument. Anyway, so that means I can play my Mary Had a Little Lamb as a piano. Still sounds awful. What about chopping down a tree? Even worse. So following the original program wasn't going to get me anywhere. It was always going to sound bad. So I also wanted to change the method. It would no longer be compatible with the previous program, but would always create something musical, and the music created would be directly related to the inputs that I was giving to Minecraft. My idea is to use a bit of music theory, because I know a little bit of music theory, hopefully enough to make something music-like. Now, I'm going to be simplifying this, because 1, I don't know that much music theory, and 2, you might know even less. So in music, there are different kinds of notes that determine how long they should be played. Now, these don't actually have amounts, like play this one for 1 second and this one for 2. They have durations based on the other notes' durations, so you can kind of play the song at any speed you like. Now, the names of these notes change depending on where you're from. Here in the UK, we have a really simple system. So I'll start with the breve. That lasts for 8 beats. Each note I'll list goes for half the time of the previous note, so the next note will be 4 beats, then 2 beats, then 1. So the next is the semi-breve, then minim, then crotchet, then quaver, semi-quaver, demi-semi-quaver, hemi-demi-semi-quaver, semi-hemi-demi-semi-quaver, demi-semi-hemi-demi-semi-quaver. It's so simple, isn't it? No? Well, because I might have people that are not familiar with this system, I'm going to be using the American system, because that's more beginner friendly. Their system starts with the semi-breve. That's the 4-beat note. That's called a whole note. 8 beats is a double whole note, 2 beats is a half note, then quarter note, 8th note, 16th note, 32nd note, 64th note, 128th note, 256th note. Thanks Wikipedia for all that. Now that we know the notes, I can explain how they're used. So we're only going to be concerned with the 4/4 time signature. A time signature is the number of beats you count in for a piece of music and the types of notes that make up a beat. So in 4/4, that means that you count in 4s and you use 1 quarter note for each beat. 3/4 would mean that you count in 3s and there's still a quarter note for each beat. 3/8 means that you count in 3s and each beat is an 8th note. What does count in mean? You know when people go 1, 2, 3, 4 before they play a song? That's it. They're just counting the beats, so everything stays in time. Now, I'm only using 4/4 because the notes divide into 4 quite nicely. I'm thinking the longest note will be a whole note, 4 beats, and the shortest note will be a 32nd note, which is an 1/8 of a beat. Any longer or shorter, and that would just be ridiculous. Okay, we're almost there, but I need to go over scales. Now, I'm going to be using a piano to show this because it's easier to see than other instruments. A scale goes from 1 note and ends on the same note an octave higher. So notes repeat as their pitch gets higher and lower. An octave is just the next note with the same name. So this is C and this is C. They are just an octave apart. Now, for this explanation, I'm going to be looking at major scales. There are also minor scales, but these sound sad and I don't like being sad, so we're sticking with major. So scales follow a simple pattern of tone, tone, semitone, tone, 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 semitone. A semitone is the difference between one note and the next note. A tone is a difference between one note and 2 notes away. Now, one thing to remember is that there is no difference between black notes and white notes. The difference between C and C sharp is the same as between E and F. The piano is just laid out this way because all white notes make a C scale. To show what that means, let's start at C and do the pattern. Tone, that's 2 notes, so skip C sharp and go to D. Another tone, so skip D sharp and go to E. Semitone, go from E to F. Tone, 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 semitone. And we've arrived at C. As you saw, we just used white notes that time. But that's the only scale that does that. Now this pattern will work on any starting note. Let's try D. Tone, tone, semitone, tone, 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 semitone. That time we used F sharp and C sharp. Now, music is written in different keys. Now, like with everything here, I'm giving a simple explanation of how this works. Keys state what notes you're allowed to use in a piece of music, and they relate to the scale. So a piece in the key of C would only use notes in the C scale, so only the white notes. A piece in the key of D would only use the notes in a D scale, so would include F sharp and C sharp instead of F and C. There are 12 notes that repeat up and down the piano from A to G sharp, so 12 keys and scales. So now that I've got all that out of the way, I can explain how the new program is going to work. It will use the timing 4/4 for simplicity, because note timings are all divisible by 2. It will first select a key to play in. This will be determined by the first input, each input relating to a different key. That will determine the notes it uses. Once that is chosen, it will get the starting note for that scale, let's say this is C, and continuously play quarter notes in 4s, like this. 1, 2, 3, 4, and it will do this regardless of if we don't give any input. Now to change this, we have to do something in the game. For example, W and S will move the note up and down the scale. So starting on C, pressing W will move the note to D, then to E, then to F. S will move the note back down the scale. The mouse will change the duration of a note. So we start on quarter notes, right click will make the note last longer, so to a half note, left click will make the note shorter, so to an eighth note. A will lower the volume, D will higher the volume. Control will play a chord of the current note. A chord is the first, third, and fifth notes in the scale. So a C chord would be C, E, G. Shift will silence the music for the time it's being held down, and finally, space will reset the note to the first note in the scale and back to quarter notes. And I'm hoping with all this, we will at least get something that is music-like. Now, the first input that the program takes is a bit different, because that will select the key. So because I couldn't easily map the 12 keys to inputs, I instead used 6 inputs and gave each input 2 values. Which value is chosen is determined by if one of the modifier keys are pressed down. This might be easier to explain with a demonstration. So if I press W on its own, that will select the key of A, but if I also press down W with at least one of space, shift, or control, that will select the key of D sharp. The full list of inputs to keys is on the screen now if you're interested. So what does chopping down a tree sound like now? Not very good, but a lot better. Here's me doing some more Minecraft tasks. Well, I hope you enjoyed that video, because this is the end, so I've run out of things to attempt to impress you with. On the end screen, there will be a link to my video, Can Music Play Minecraft?, where I answer that question. If you like this video, you'll probably like that one. Goodbye!